언니 exam sheet. 김정민. If there is any mistake in grading, let me know. 문영빈. 신원태. 딜라라 에젠. 홍천희. 유시원. 메이 마틴 파킨슨. 김일현. 이민현. 이윤규. 한수현. 김조은. 전성현. 윤선우. 김소비. 신주환. 조은찬. 요하나. 김태윤. 이영소. 태영. 남시은. 송현. I can read for you. 김수하. 송현석. 황규리. 제이미. 이주호. 펠릭스 오토. 김찬민. 김유진. 미키. 정은진. 이유정. 엄범. 레지아스 가브리엘라. 문지원. 이정준. 양태경. 이정민. 명채. 이승연. 하영석. 우영진. 김지우. 홍지환. 정희철. 서리. 네? 아. 박서린. 옥나경.
제가 박서진이거든요.
아, 박서진이에요.
네.
이건가 보다.
이거
이정민.
유시.
유시.
네.
수정. 유시. So students online can visit my office, or you can get the email. I can send you an email for what you got wrong. So if you want to check your exam, please let me know. The cutoff for A plus was in the syllabus. It was 95%. Actually, this one accounts for about 30% or 40% of the total score, right? So if you got 100 points for this midterm exam, you got 35 out of 100 in a total score, right? Altogether, you need to get above 95, right? for now. I can lower the cutoff for A+ only after you take the final exam. I'm going to adjust the cutoff line for A+. And let me check your attendance with this exam sheet. May Martin Parkinson,
Here, Professor.
yeah. Chun Song-hyun,
Yes, Professor.
please raise your hand if you're present here. Johanna Elma Sadelli and Choi Young-in. Kim Soo-ha. Lee Nikki Lee. Medias Gabriela. 이정민. 옥나경. 사티람닷.
I'm online, Professor.
Yeah, you need to return your exam when you on your way out after the class. Don't forget to return your exam. You can join this class either online or offline throughout the whole semester. So you can pick whatever you want. And let me share the Excel file. Or the demand forecasting. So last time we saw simple moving average, weighted moving average, and exponential smoothing, and Holtz model, right? The Holtz model can be used when there is a trend in demand, and you update both level and trend of the forecast and get the final forecast. So you consider the trend when you use this Holtz model, and the Winters model can be used when there is both seasonality and the trend. So we got the seasonal factor last time using this base deseasonalized demand, this column, which is the weighted average for 5 past demand, and the deseasonalized demand, which is the which is based on the regression analysis of this base deseasonalized demand. Right, we got this deseasonalized demand, which is the demand without seasonality, using the weighted average of the 5 relevant demand. Right, so for this one, we use this 5 demand, and for this one, we use a weighted average of these 5 demand, so on and so forth. And using this deseasonalized demand and the period, we run the regression analysis. And the regression analysis shows the y-intercept and the slope of the regression line. Right? Using this, we can estimate this whole the decisionalized demand for whole period. Right? So this is the y-intercept plus slope times period 1. Right? This one is y-intercept plus slope times 2, so on and so forth. Right? So using this regression line, we estimated this decisionalized demand. And using this decisionalized demand and the actual demand, we got the seasonal factor. Right? Since this deseasonalized demand is a demand without seasonality, and if you divide the actual demand, which has the seasonality, by this deseasonalized demand, you can get this seasonal factor. Can you see the relationship between these three? If you multiply this deseasonalized demand by the seasonal factor, you will get the actual demand with seasonality. Right? That's why we divide the actual demand by this deseasonalized demand to get the seasonal factor. So using the same formula, you can get the seasonal factor for this all 12 period. Right? And using this seasonal factor, base of the seasonal factor, you can get the actual seasonal factor. So this first one is the average of every first seasonal factor. So it is assumed that the cycle is 4, cycle period of cycle 4. So every 4th period, the seasonality comes back. So here 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3, 4, so on and so forth. So the seasonal, the period within one season is 4. So the seasonal factor for the first period is the average average of this every first seasonal factor in the base seasonal factor. So the average of 0.42, 0.47, and 0.52 will be 0.47, and this is the first period seasonal factor. In the same way, second season seasonal factor is the average of every second season seasonal factor. So this is the average of 0.767, 0.83, and 0.55. In the same way, you can get the third seasonal factor and fourth seasonal factor. So we are going to start with these 4 seasonal factor, and the level, which is the y-intercept of the regression line, and the trend. So these yellow highlighted values are this initial value for the initial seasonal factor, initial level, and initial trend. And the level here is defined as the demand without trend or seasonality. So initial level and initial trend. Initial trend is nothing but the slope of the regression line. After getting this initial seasonal factor, initial level, and initial trend, we are going to update every component of this Excel file. So we are going to update seasonal factor, update level, and update trend. If you compare this Winters model to this Holtz model, in the Holtz model, there were 2 initial values, level and trend, and we updated both level and trend to get the forecast for the next period. Right? We update the level, update the trend, and get the sum of this level and trend to get the next forecast. Right? And then again, we update level and trend, level and trend. And in the Winters model, like the Holtz model, the level and trend are also updated, and also the seasonal factor will be updated. So starting from this initial values can get the forecast in period 1, which is the sum of level and trend times the seasonal factor for this period. So here, we get the sum of level and trend and multiply the seasonal factor to consider the seasonality of this demand. So this is the forecast. How about this? The forecast in period 2 is nothing but the sum of level and trend for the previous period times the seasonal factor for the period 2. So if you double click this one. So forecast in period 2 is the sum of level and trend in period 1 times the seasonal factor in period 2, so on and so forth. In the process of getting this forecast, you need to update both level and trend, and also the seasonal factor. So if you look at the level in period 1, this is the weighted average between what? Between this. See, so actual demand in period 1 over the seasonal factor in period 1 will be the deseasonalized demand, the level for this period, right? See, the cell C4 represents the actual demand in period 1, and the cell G4 represents the seasonal factor in that period. Right? By dividing the actual demand by the seasonal factor, we just deseasonalize the demand, right? Which is the same as the level. Right? Level times the weight. In this case, we are going to use alpha 0.05 as the weight for this level. And then we have another component in this level, which is the sum of the level and trend from the previous period. So here, these two is another component in this weighted average. We add this level and trend, initial level and trend. This is one component. And another component was the deseasonalized demand, which was the actual demand divided by the seasonal factor. And then we got the weighted average between those two. So let me use the whiteboard to make this clear. So level in period 1 was the weighted average between this and this, right? The weight was alpha 1 minus alpha here. So weighted average between this component and this component. Right. And this demand in the first period over the seasonal factor in the first period is considered as the deseasonalized demand. And this one is nothing but the forecast in period 1. So this updated level in period 1 is the weighted average between this deseasonalized demand and the forecast, where the weight is alpha and 1 minus alpha. Using numbers, the updated level was 18,866. This was the weighted average between this and this, and we use alpha as 0.05. So the weight for this component should be 0.95. So if you generalize this update, level in time t will be the deseasonalized demand in time t, and the sum of level and trend in time t minus 1, and the weighted average of these two. Or this is the same as dt over st times alpha plus ft, which is the forecast in time t, times 1 minus alpha. So using this formula, you are going to update level for every period. Then how about trend? Trend. And you also update the trend by using the weighted average between two components. The first component is the trend in the previous period. And the next one is the gap between the level for this period and the previous period. So gap between these two will be one component of this weighted average. And the trend in the previous period is another component in the weighted average. And here, we're going to use the beta for the weight, and the beta is given as 0.1. So let me use the whiteboard again. So now we are going to update the trend. Trends in period 1 is the weighted average between the gap between updated level and the initial level. And the trend from the previous period. Now the weight is beta and 1 minus beta. Using the numbers, the updated trend was 514. This is the same as the gap between updated level and the initial level times beta plus the trend in the previous period times 0.9, which is 1 minus beta. And if you generalize this formula, then trend in time t the same as level t minus level in t minus 1 times beta plus trend in the previous period times 1 minus. Using this formula, you're going to update the trend for every period. So it will go like this. You get the initial level and trend using the regression analysis. And you got the seasonal factor using this seasonalized base demand and deseasonalized demand and the base seasonal factor. Right? So using this initial level and trend, you can get the forecast for this period 1, this one. Right? And then you can, after the demand in period 1 actually happened, you can update the level, right? Using this actual demand and seasonal factor and what else? The trend, right? Using these values, you can update the level, right? And you can also update the trend using these values. After updating level and trend in period 1, you can get the forecast in period 2, right? Which is the product between the sum of these two and the seasonal factor, right? Level 1 plus trend 1 times seasonal factor in period 2. And then what? After the demand in period 2 actually happened, you can also update the level in period 2, and you can update trend in period 2, right? And using these two value and the seasonal factor in the next period, you can get this forecast, so on and so forth. And then after this forecast, you need to update the seasonal factor because we only have this 4 initial seasonal factor. How do you update this seasonal factor? Seasonal factor is here another weighted average between 2 components. One component is the seasonal factor from the previous period, and another factor is actual demand over this level here in the first period. So the first component is this 2, demand over this level, actual demand over the level, and the next component is the seasonal factor, the first period. Because this is the seasonal factor for another first period, right? First, second, third, fourth, and then first, second, third, fourth, right? Every 4th period, the seasonality comes back. So for this one, you need to use this history data in period 1. And for these 2, and let me use whiteboard again to get the formula. So seasonal factor in period 5 was the weighted average between demand 1 over to 1 and the level in period 1. And here the weight is now gamma, and gamma was 0.1. To use letter rather than the number. Right. Using the numbers, 0.47 is the weighted average between this and the level, where the weight is 0.1 and 0.9. So to generalize this one, seasonality in, let's see, P plus 1. Here, P is the number of periods in one season, one cycle. So every fourth period, the cycle, the seasonality comes back. So here, our P is 4. Actually, P plus T. The seasonality in time P plus T will be dt over st times gamma or t times 1 minus. Right. And in our case, P is 4. So that's why for the seasonality in period 5, we use D1, S1, right, and L1. When the number of period in one cycle is 6, you can get the seasonality for what? From the 7th period. This one is like this. Right. When P is 6, you can get the seasonal factor in period 7 like this, but we have the period P4, so in that case, seasonality in period 5 can be computed like this. So this is the formula to get the seasonal factor, updated seasonal factor, when the number of period in one cycle is P. Using this, you can update the seasonality for every period. And yeah. Well, yeah. Let me check.
Well, I think you miswrote the denominator for 0.47. I think it should be 18,000.
No, I got this number from this Excel. Let me check.
Did you swap out the 0.47?
This. Oh, yeah, the next component should be the seasonal factor, not the level, right? Right. Oh, I got wrong for this formula. So these two, if we, so the one component should be the demand over the level, right? The other component should be the seasonality from the previous past data. So let me
음,
So, just regarding the P variable. So you're saying like P is the number of years in one cycle.
Number
So
of
like,
period.
For example, if we're counting like by month, then there's 12 months, so there's 12, so we would count like the first returning P as like, we would count the first one as that's 13,
13?
or is it not?
Yeah, if the seasonality comes back every year, right, and the unit of analysis is the unit is month, yeah, then the P should be 12.
And like if we were counting a trend where the trend repeated every 8 years, then the P would be 8. So the first one returning would be S9.
Yeah. So I should switch the values. This one should be L. Right. This one should be S. And then in the number, the numeric example, this one should be level, right? And the seasonal factor. And I need to erase this two. So right. So the weighted average between the seasonality, one kind of seasonality that was computed using this actual demand and the level and the actual seasonality. Yeah. And then going back to this Excel. So after this period 4, you don't have the seasonal factor. So after this period, you need to update seasonal factor for every period whenever the actual demand appears. So you update seasonal factor, level, and trend. Actually, level and trend in the period 4 and updated seasonal factor in period 5 to get the forecast in period 5, right? Which is the product between the sum of level and trend and the seasonal factor. So those are the models that you can use based on the demand pattern. And after getting the forecast, you can evaluate how much your forecast method was accurate, the performance of your forecast method using several measures. And the first measure is, if you go back to this simple moving average case, let me explain these four different measures of this forecast method. First one is the error, simply the gap between the forecast and the actual demand. You can get error for this period by subtracting the forecast from the actual demand, right? So this error in period 5 is 10,000 minus 19,500. So very simple concept. You just compute the gap between the actual demand and the forecast. And when the error presents a negative value, it means that your forecast was overshooting, right? your forecast is more than the actual demand. When the error shows the positive value, means your forecast is undershooting. Forecast is less than the actual demand. So then altogether, if you get the sum of this whole error term, you can get the cumulative, what does this F stands for? Cumulative error. Cumulative sum of forecast errors. This is this is nothing but the sum of the error for every period. And this cumulative sum of forecast error shows the bias of your forecast method. How biased your forecast method from the actual demand. And the next measure is the absolute error, simply the absolute value of error. And using this absolute error, you can get this MAD, which is the mean of the absolute error deviation. This deviation. Mean absolute deviation. Mean absolute deviation. So the mean of this absolute error. And you can also get the mean of the squared error, which is based on the squared error. So you just square the error for each period and get the mean of this squared error to get this MSE, mean squared error. And this MAD and MSE measures the deviation of the error. And can also get this percentage error. Percentage error is the percent of this error based on the actual demand. So this one is minus 9,500 over the actual demand, 10,000 times 100. So it shows the ratio between the amount of error and the actual demand. And then you can get this absolute percentage error, which is just absolute value of this percentage error. And if you get the mean of this absolute percentage error, you can get this MAPE, mean absolute percentage error. What does this mean? Mean absolute percentage error. Yeah, it shows how accurate your forecast method is. And so using these four measures, you can evaluate the performance of your forecast method. Right? You can compare these measures for 2-period moving average and 3-period moving average, 4-period moving average to pick the number of periods in your moving average method. Right? Or you can compare these measures across another forecasting method. So using the same formula, I got the CFE, MAD, MSE, and MAPE for weighted moving average and exponential smoothing, Holtz model, and Winters model. If you compare these measures across different forecasting methods, which one performs the best? Yeah, Winters model. If you take a look at this MAPE alone, right, the MAPE for this Winters model is lowest. So using this demand for 12 period, we can conclude that Winters model is the appropriate method to forecast the demand, Why is that? If you take a look at this demand, you can see both trend and seasonality, right? There is a trend. The demand is slightly increasing and the seasonality. So every fourth period, the seasonality comes back. This is why you need to examine the demand pattern before you select the appropriate forecasting method. Right? Since this demand shows both trend and seasonality, Winter's model should be the best model because it considers both trend and seasonality, update trend and seasonality, right? So the second case is about this forecasting method, about using various kind of forecasting method. So I posted the second case. So in course material tab, you can check the problem sheet for case 2. It says the file name is case number 3, but actually it's case 2. So please check this file, and the due date is on May 26th. So you need to submit the hard copy of the solution that day before class. And what time is it? So the measurement to evaluate the performance of the forecast method is like this. You can see the formula for this. And I'm going to post the formula for this Winters model and Holtz model after this class, maybe tonight.
짐 싸들고 갈 게 많아요. 자, 이렇게 DP도입니다.
뭐죠? Oh, let me stop here. Because in next chapter is about the inventory management. Inventory management, and it also has a lot of calculations and probability distribution. Let me stop here and yeah, that's it for today. Let me go. If you find any mistake in grading, let me